Good morning, guys. Today we'll continue our second lesson in SAP, and what will you learn in this session is the power of a good quality notification to support total reliability, lean manufacturing and constant improvement. What you will not learn are your company specific work processes. I'm sure that will come later. We'll keep that slide in from the last show, because it's a reminder that every production facility's aim is to achieve total reliability, lean manufacturing, constant improvement, and remember that the maintenance budget is initially based upon carrying out maintenance PPM tasks, not correctives. Therefore, every repair activity is an additional to the PM budget and prevents PMs from being carried out. It should be every maintenance department's goal to minimize the creation of corrective tasks. One of the underestimated functions and rarely used tools in defect elimination is here in the notification. On each function location there is a minimum of 5 basic codes for most maintenance equipment. There is failed to start and stop on demand, fail to stop, close, de-energize on demand, fail to operate as expected, fail to PM inspection, or not applicable. The not applicables are there should you want to have a wall painted to employ some scaffolders, or maybe have a floor cleaned, that kind of thing. That's not a maintenance defect, it's just somewhere to capture those costs to. When the originator of the notification raises the defect, he should select one of these codes. Identifying defects during the PPM is considered the most efficient way of identifying a potential threat. It is a critical tool in defect elimination. So, in line with constant improvement, if after a period of time, now a period of time could be any duration, 6 months, 1 year, 5 years, and we review SAP and find that a particular department had 3,458 notifications raised against them, and have been converted to work orders for one particular department and then released. It might be that the fault codes have been entered like this. Of the 3,458 notifications raised, 519 were identified as failed to start and stop, 726 failed to stop or start, 1,176 failed to operate as expected, 865 failed a PM inspection, and 173 were not applicable. That is the graph for that particular activity, and they are the cause codes that were entered against these work orders on closure. And we see that they've used C075 operating error, as 15% of their workload was operator error on the review and findings after a cycle of period in time. If we investigate the reason codes and find that the percentage of failed as failed to operator error, we find that a simple sign showing the operator instructions, or a label showing the set points, what the set points should be, would have eliminated these 515 distractions from the PM workload. You minimize your cost, that defect will never come again for the menial task, if you like, of going sticking a label on. Most maintenance departments say, not my job, I'm a superstar, I don't fit labels. You tell them, I've told them not to touch it. Get beyond that, go and fit the label, put a marker on the equipment saying what the set point should be, let them know how to use it properly. This is lean manufacturing, Henry Ford. This simple action would eliminate these defects from potential happening again and reduce the distractions from the planned work. That is waste reduction, wasting your time and the blue lines are in the bottom there again, reminding you that our budget is for PMs only. What makes a good quality notification in the long text? What you should have is a comprehensive explanation of the fault, where it is, what the reason we should repair it, and any special considerations and precautions that we might need to know before we start this job. What is required to repair the defect, and we need men, the method, and the materials they're going to use. So in this hypothetical situation here, we've identified that a pump 1234 located on the methanol plant on the east side of the ground floor, and it's local to the safety shower, which is identified as SSABC, which can be found on the emergency plot plan. Well, that's made that location easy for anybody to find. You might know where this equipment is, the scaffolders won't, the planners won't if we have planners employed and they need to go and review this job. You've just made it easy for them to find. And give them a simple explanation. The pump tripped in service without warning during the transfer of toxic materials to the storage tanks. Operator in the area attempted to investigate the equipment. There was no obvious obstruction or cause. He attempted a restart without success. He tried to rotate the shaft offline manually, but it will not turn. That's basic troubleshooting. The kid's done his job and he's tried to do something. The duty was switched to the standby pump. The standby pump already has a notification in place reporting high temperature alarms. So he's telling me that this pump is also not reliable. It gives the urgency of repair to this pump 1234 a higher significance. So what are we going to do? The pump requires an investigation by the mechanical team. They're going to need a lifting frame, they're going to need lifting equipment and rigging services. They will require an electrical isolation, they will require the instruments to be isolated, it will require a mechanical strip down. And if you had a good enough relationship with these other guys, you could probably guess or speak to them and estimate durations of time for this job. In this troubleshooting exercise, we have not identified any materials we need. At this point, we don't know. So we can put a note in there saying, on completion of this troubleshooting exercise, a new notification will be raised to order any required parts for and consumables. Special note there at the bottom, the pipework contains toxic materials and there will be a residue even though the lines have been flushed. Special precautions apply. This is good practice to generate a long text template in the notification for companies to request this information. But sadly, not everybody does, and I'm sure you've seen good and bad quality notifications in your company. And I've put the original graph that we started with, about 45% planned work, 30% breakdowns, 25% waste, in this slide to show you this is how we tackle that 25% waste. We are planning up front, and that simple step there, which might have taken us 15 minutes to write that notification, that has just gone somewhere for the systematic method for waste minimization. When the work order is complete, if the correct functional location has been used to create this notification, we will get a closeout report, and in that closeout report we will have a section which requests any comments on the plan. Is there anything that needs to be changed? Are the planned work centres correct? Is there anything that needed to be changed in the planned man hours? Other comments, any special tools, materials, equipment. It's asking you to constantly improve this type of task. And then we've got to do the closeout report. So it started as a failure code, failed to start and stop, operate as demand, operate as expected, fail to stop. We're going to choose it failed to operate as expected. That's what you would have expected to see as the code in the notification. When we get there, now we might find that the object parts for the failure is not applicable, and I'm leading you down the path here of getting to the place where it was operator error. So we would tick not applicable in the object section, and then the next one is the description of which equipment. Well, that would be not applicable again. And then the causes: expected wear and tear, fab installation causes, general design, and getting down there to the bottom, C075 operator error. And you might say that the operator had sealed off or closed or not opened the valve that was feeding cooling fluid to the mechanical seal on this pump, and that's why it seized up. Now the simple steps are that you could have a checklist on this job saying, operator, before starting this pump, ensure gauge reads, this valve is open, this valve is closed, this is that, this is that. It's simple. Even the operator could write it for you, an experienced operator in that area, for any new people joining the company. And once it's done, it's on the wall, and you should never expect to see this failure again. So respect the requirements of the closeout document. There is only one opportunity where we can gather this information. Once the equipment is back in service, all the problems incurred will be forgotten, and we move on to the next repair. Once we complete this documentation for constant improvement and we've captured this data, this is all entered into the notification again under the multi-items tab. The technicians might do it on closeout, or you might be lucky enough to have a technician who enters this information. But it goes into this sheet, and that's where it stays forever, and that is where it will be analysed from by a review party at a later date. Constant improvement, we spoke again. Only the maintenance team will ever look back and read the long text of a notification to investigate what we found last time. How much oil we topped it up by? Was there a reduction in pressure? Is there any indications of failure that might be coming up? And what we did to correct this defect. Good previous history is key information to the maintenance tech. The analysis group will search the fields and use the codes of the notification. They won't use the long text. Expected wear and tear as a high percentage indicates that the PPMs are either not being carried out correct, or the frequency is incorrect, or they're not being done correctly. The technicians are reporting this. The technicians themselves are reporting this. What does the original equipment manufacturer recommend as the lifespan for this equipment should be? Now the original OEM might say that, well, that valve there, if maintained correctly and used correctly, will last you 15 years. And if we are getting expected wear and tear for a particular valve after 2 years, there is something wrong with what we're doing. And constant improvement asks us to review this information and take the time to investigate and dig deeper, find out what it is, and recommend changes to the company. You will continue to reduce that cycle and eliminate waste. And sadly, guys, that's what the job is. I remind you that every production facility's aim is to achieve total reliability, lean manufacturing, constant improvement, and remind you at the bottom there that we're only here to do maintenance. We're not here predominantly to do fixed things. Our job and our budget was based on the PPM. Thank you very much for your time, guys. That's the end of that show. In the next lesson, I'll show you how to write a good quality notification in a notification, and then we'll look at how it transfers to work orders, and in the next lesson after that I'll show you how to schedule in IW32. Thank you very much for your time, guys.